And this is Mrs. Bump, and this is my first attempt at recording a lesson while I will be gone on maternity leave. So today you guys are going to be learning how to factor. All right, the lesson is on factoring. So if you're taking notes, this is going to be section 2.2, the second section of the quadratic unit, and it's going to be on factoring quadratic functions. Maybe I should change my pen to calligraphy here because, oh, it's already on that. That way you can actually read my writing. You know I write so sloppy. So factor. What is it? What the heck is it? We talked about at the very beginning of the year when we were trying to isolate y and there was more than one y. So we had to factor that y out of both terms to be able to isolate it. That was an example of factoring out a GCF. There are many other ways that you can factor. Factoring is essentially like undistributing the problem. You can think of it as if I had to find like the factors of 6 in the sense of like middle school. You could say factors of 6 are 1 and 6 or 2 and 3, because when you multiply them, you're going to get back to 6. In the more complex examples that we're going to be doing, it's not just numbers. We're going to be dealing with expressions with multiple terms. When we learned how to distribute a binomial times another binomial, factoring would be doing the reverse of that, which we will learn how to do today. In terms of quadratic functions, and apparently the calligraphy pen's not working, factoring is going to be the process of going from standard form to what we have been calling intercept form. Right. So you're going from the ax squared plus bx plus c format into the a times x minus p times x minus q format. There's going to be a very special relationship that we will learn about throughout the entire school year in how these factors relate to the zeros or the x-intercepts or the roots of a function. That has a very special relationship that will come up multiple times throughout the year. Some other vocab words that I'm not going to define or formally write down that you will hear me using, the word monomial, that means a single term. Binomial, like the x minus p and the x minus q, those would be binomial factors. The a would be a monomial factor. The standard form I will refer to as a trinomial. It has 3 terms. And then again, just the usage of factor versus term when we are factoring these quadratic examples. The first step, what we're going to start off with, is factoring out a GCF. So for all of these examples, we are going to factor out a GCF, or a greatest common factor. So we're going to look at every single term to see if they have something in common that we can remove, undistribute from each term. This is always the first thing you should look for before approaching any factoring problem, and then sometimes there will be additional steps after you factor out the GCF. So first example, I gave you 16x squared plus 36x and asked you to factor that. You would look at each term in our binomial and see what they have in common. Well, 16 and 36 can both be divided by 4. Both terms also have at least one x. Therefore, the GCF of this problem would be 4x. And that's what we're going to factor out of each term. When you're factoring it out, you're dividing it out of each term. So the 4x becomes a monomial factor, and you set up your parentheses, and you have to ask yourself, well, 4x times what first term here would give me my 16x squared? And the answer to that is another 4x, because 4x times 4x is 16x squared. 4x times what expression here will give you the 36x, and that answer is positive 9, because 4x times 9 is 36x. The nice thing about factoring is you can always check to see if you did it right by redistributing at the end. So if you redistribute this 4x, you should get back to the original problem. This is our solution. This cannot be factored any further. Another example of factoring out a GCF. If I gave you negative 27 n to the 7th plus 6 n to the 5th plus 6. Looking at each term in this trinomial, there are a common factor of 3. So the GCF would be 3. And then they don't all have an n, so we can't factor out any n's because this last term here doesn't have an n. So all you would do is factor out a 3. However, you usually don't see leading terms in a factor that are negative. So I'm actually going to factor out a negative 3 from each term to eliminate that negative leading term that would be in the trinomial factor. So if we take out a negative 3, dividing these all by negative 3, we will get positive 9n to the 7th minus 2n to the 5th minus 2. So your signs are going to change when you factor out the negative, but now you will notice this first term here does not have a negative coefficient, which we don't want it to. And that's as far as that example will go. The last GCF example we're going to do is 28y cubed x to the 7th minus 63y x to the 4th. While you guys are watching this, you might, need to pause here or there. Since I'm teaching to an empty classroom right now, I might be going quicker than I would when I'm going in class to pause for questions and things like that. So feel free to pause at any point if you need to process the information. Looking at all of these terms, our GCF between 28 and 63 is going to be 7. They also both have at least one y, and then they both have at least 4 x's. So our GCF is going to be 7y x to the 4th. And technically I might rearrange that a little bit to put them in the order of the alphabet, but you don't necessarily have to. So if we factor out 7y x to the 4th, we have to figure out what remains. So 7 times 4 would get us back to the 28. To get a y cubed, I would need a y squared here, because y times y squared is y cubed. And I factored out 4 of the 7 x's, leaving me with 3. And if you were to redistribute x to the 4th times x to the 3rd is x to the 7th. In terms of the second term, I'm going to have minus 9, because 7 times negative 9 is negative 63. This y has been factored out, so it's no longer there. And we also factored out all of those x's, all 4 of them. So there's nothing left in the parentheses. And there is our final answer. So those are some examples of factoring expressions by identifying and factoring out the GCF. We're going to move on to more traditional quadratic trinomials now. So normally I would give you guys this example. So factoring quadratic trinomials is the topic. And the ones that we're going to focus on today, the a values are all going to equal 1, or we can make them 1 fairly easily. So these are basic quadratic trinomials. So I would pose the question to you, if I gave you x squared minus 2x minus 48, which is a quadratic trinomial, and we were to factor that, it would have to factor into 2 binomials. And I would give you guys a few minutes to play around with it and see if you could figure out what goes in each binomial, so that if you were to distribute it all out, you would get back to x squared minus 2x minus 48. But since I am sitting in an empty classroom right now, I feel foolish standing here for 2 minutes staring into space. So I'm going to move forward, but feel free to pause. The first term in each binomial has to multiply to x squared. So in order to get x squared, I need an x times another x. The second term in each binomial has to multiply to the c term, to the negative 48. So to figure out what goes here and here, we're going to find factors of 48. And you could list them all out, or you might just know them off the top of your head. And what you're going to be keeping in mind is when you're listing factors of 48, those factor pairs also have to add to this b term. So they're going to have to add to negative 2 or subtract. So for 48, 1 and 48 would be the first factor pair. There's no way if I add or subtract those that I'm going to get a negative 2. The next pair would be 2 and 24. Again, no way if I add or subtract those I will get negative 2. Then you're going to have 3 and 16. Again, if I add or subtract 3 and 16, I'm not going to get negative 2. 4 and 12. Still will not add or subtract to negative 2. 6 and 8. Ding, 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 ding. We have a winner. Okay, there is a way to get negative 2 out of 6 and 8. So they have to multiply to a negative 48. So I know that in my binomials, one has to be positive and one has to be negative in order to get a negative c value here. And then when I combine them, I need negative 2. So to make that happen, the 6 needs to be positive and the 8 needs to be negative. If you wanted to double check, as long as you chose 6 and 8 because they are factors of 48, then you don't have to check by distributing it all out. You could just check the outer and the inner terms, which would be negative 8x plus 6x, which does add to negative 2x, which matches the original trinomial. So the answer to this question would be x plus 6 times x minus 8. It's a lot of guessing and checking. The more you guys practice these, the quicker you're going to get at it and the better you're going to be at it. When I learned this back in 8th grade is when we learned how to factor quadratics. My teacher used to give us worksheets with like 200 questions on them and make us do them over and over and over and over and over and over again, so we got really fast. This is such an important skill, and it's going to show up in so many other units and so many other math courses. So it's something that you need to take very seriously, because if you don't master it now, you're going to be struggling not only this year, but in future years as well. We're just going to go back and label this as example number 1, so we can do a couple more trinomial examples. Actually, before I do that, let me formally just write over here. What we just did is we find factors of c that will add to the b value, okay? But you have to pay attention to the sign of c. That's important. Pay attention to the sign of c, because that's going to tell you what your signs and your binomials have to be. Here's another example. X squared minus 16x plus 60. Now 60 has a lot of factors, but if you're really good at your multiplication facts, you might be able to narrow it down pretty quickly, seeing as though you're trying to find factors of 60 that add to negative 16. This time c is positive. What that will tell you is in your factors, the signs need to be the exact same, either both positive or both negative. And to figure out which case you have, you look at this b value. So since our b value is negative, both signs in our binomials will be negative. A negative times a negative will give you a positive 60. And when you combine the negatives, you will get that negative b term in the center. We're also still going to have an x and an x because our leading term was x squared. And then you probably could figure out fairly quickly the factors of 60 that will give you 16, which I would pause if you need some more think time, but I'm going to give you the answer of negative 10 and negative 6. Because negative 10 minus 6 will give you negative 16, and negative 10 times negative 6 would give you positive 60. So there is our solution. We are now in intercept form from standard form. We've got 3 more for today's lesson. X squared minus x minus 30. You can always set up your binomial factors right away. And you're going to start thinking about your factors of 30. You could list them all out. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And you're trying to find the combo that will add to negative 1. Our C is negative again. So that means in our binomials, we need 1 positive, 1 negative, and the winning combination will be 6 and 5. We want a negative 1 in the center, so therefore the 5 is positive and the 6 has to be negative, because 5 minus 6 is negative 1, and 5 times negative 6 is negative 30. These last two are going to be a little different. Okay. This one has a leading term that is negative. It's a negative 1 for an A value. First thing you'll do with these type of problems is factor out a negative 1. We don't want that leading term to be negative inside our binomial. So if I factor out a negative 1 first, so think of it like your GCF, all that will do is change our signs. Nothing else changes. Then we're going to work with our new trinomial, x squared minus 8x minus 20. We'll drop down our negative a value. Think of that, the negative 1a value there. And set up our 2 binomial factors. First terms of each of them would be, answers please. I feel really silly. X and x. And factors of 20, that will give you 8, are going to be 10 and 2. The C is negative, so 1 positive, 1 negative. And in order to get negative 8, we are going to have to do negative 10, and positive 2. Just had a weird ringing in my ear. I'm hoping that doesn't mean this thing is shutting off and it's still recording. So this would be our final answer. I'm going to just pause real quick to pull up the recorder button to see if it's stopped. Nope, it's still going. And continue on with the very last example. So we have 2x squared minus 18x plus 36. This is also different because our a value is not 1 again. Here our a value is 2. Tomorrow you will learn how to factor trinomials where the a value is not 1, but since today we're focusing on the a value of being 1, we can make it 1 by factoring out first a GCF. A GCF should always be one of the first things you look for. So if we factor out a GCF of 2 from all of our terms, that will leave us with x squared minus 9x plus 18. Now, within the parentheses, that trinomial now has an a value of 1. So we can break that into our 2 binomials using the strategies we were just learning by finding factors of 18 that add to negative 9. The C is positive, not negative, so we have to have the same signs in our binomials. So that's when we looked at that middle B term. Because the middle B term is negative, these are both going to be negative. And the winning combination that will multiply to 18 but add to -9 will be -6 and -3, because -6 times -3 is +18, and -6 minus 3 is -9. So there's our final answer. Make sure you guys don't forget to bring down that GCF that you factored out in the very beginning. Otherwise, if you were to redistribute, you would not get back to the original problem, which you would need to. On your homework tonight, the number 15 is going to be a little challenging. It's going to lead into tomorrow's lesson where the A value is not 1, but I still want you to try it. So you guys have a practice worksheet with a bunch of examples where you get to try factoring these trinomials or GCF examples on your own. I hope you guys were able to follow and understand what I just taught today, and I will keep recording more lessons. Bye, guys.